Now we are going to study about the convolution layer. The first layer in the CNN is called the convolution layer. And in the convolution layer, we perform convolution of particular feature. What is the convolution? Convolution is a process of trying every possible position. Here we will move the feature to every possible position. Okay, let's understand what will be happen here. Basically, inside this, I can explain you through a Excel sheet. Like we have a image like this. This is the 7x7 image, and you can see this is a smiley image. Here we have pixel value 0 or 1. 0 means it is a black pixel and 1 means it is a white pixel. So I have a black and white image, and for doing the convolution of features, what I need to do, I need to take a feature detector. I need to choose a feature detector, or you can say a filter, or you can say a kernel. So here I have taken a kernel of 3x3, and the values inside the kernel can be random, it can be anything. And size is also your choice, you can take any size. Okay, so generally we are by the best practice we are taking 3x3 kernel, odd number kernel. Okay, now the process, what we are going to do here, we need to put this filter over this image. Then we are going to put this filter, and we are mapping every pixel value. Like we are going to multiply every pixel with the corresponding pixel with the filter. Like I'll show you what we are going to do. Like this first pixel multiply by the first pixel of this filter. So here I'm writing 0 into 0, and then we will sum plus the second pixel of this multiply by the second pixel of this. So 0 into 0 plus third pixel is 0 into 1. The first row is completed. Now come to the second row. Here we have 0 1 0, and here we have 1 0 0. So I'll multiply 1 by 1. 0 into 1 plus 1 into 0 plus 0 into 0. Okay, and now what we will do, we will sum all these values, and you can see here the sum would be the 0, and this is the first pixel value we will calculate after the convolution. We need one more term here, the stride of 1. Stride of 1 means we are taking a stride, like we are shifting this filter or this kernel by 1. From first we are moving from left to right, so we are shifting this filter 1 to right pixel. Okay, again we will do the same process. We will multiply each pixel by corresponding pixel. Okay, and at the end we will calculate the value of the next pixel. So you can see in the case of second, we have exactly this is the pixel, this is the original image, and this is the filter, here the 1, and at the same position we have 1 in the filter also, so the value would be the 1, right? You can do the calculation, you can practice, and you can see what is happening here. I have even written the formula also here. So basically we will shift again like this, and then we will shift again by 1. Okay, and then we will shift again by 1. Okay, and when I'll complete one row from left to right, then I'll move towards the downside, then I'll follow the same procedure. Okay, so I calculate this matrix, and this is my new image, this is my convolved image. Okay, getting? This is little bit tricky. You can listen this video carefully, then you will get it. And this is the one filter I have taken. I can take lots of filters. Like the second filter, I have taken this. So the same image I convolve with the different filter. Then the output would be like this. Okay. So similarly, we will perform the same convolution with every other filters. Like here I have taken 2 filters. It's your choice how many filters you want to take. Like I have taken 2 filters, so I will get 2 output images. So now we will have a stack of filtered images. These are the filtered image 1 and filtered image 2, and it can be more. Like if you have taken 10 filters, then you will get output of 10 images. Okay, so I can say in the convolution one image become a stack of filtered images, or the number of filtered images depends on the number of filters. This is the step 1, the convolution. Now come to our article, and now you can understand this very well. Okay, this calculation can be done like this, and this is the convolved feature. Okay, and we can take the stride of 2 also. Like in this case, if I'll take the stride of 2, then what will happen? I need to, like, first this is the red one, and after this red one I'll shift by 2 pixel. This is the purple one and then the green one. So I'm shifting by the 2. So if stride of 2 means we get the smaller size convolved image. Okay, and this task we have applied with the black and white image or grayscale image. If we have RGB image, then what we will have? We have 3 channels of an image. Okay, for that what we need to do, we need one kernel for each layer, like kernel 1, K1 for the L1, K2 for the L2 and K3 for L3. So for every layer we need a kernel, and after that all the results are summed up with a bias to give us a final convolved feature output. So we are extracting high level features from an image. And there is the another terms called the padding, and the same padding or valid padding you will see further when we are going to do the practical part. Then you will see I'll use the same padding. What does mean? So suppose I'm taking an image, like we have an image 5 cross 5 cross 1, and we want to apply a filter 3 cross 3 cross 1. Then what will happen? In the first time, like 5 cross 5 cross 1 image, first filter is shifted. In this case, what will happen? My output matrix will become 6 cross 6 1. So basically it is difficult to calculate. In this case, what we will do, we will add one padding to input image. Like when we are shifting towards the right side, then it will have only the 2 columns and we need the 3 columns for 3 cross 3 cross 1. Okay, so we can add the padding will be added by the 0. So this is nothing, this is simply we are adding the padding to the input image. So this is all about the convolution layer.